Hello guys, my name is Bappy Ahmed and welcome to my YouTube channel. So guys, this is going to be one amazing video. So here we'll be implementing one awesome project called license plate extraction with the help of Yolov10 as well as the PaddleOCR. That means we'll be detecting the license plate, then we'll be also extracting the license plate information. Okay, not only that, after extracting the information, I will also show you how we can store these are the information to the database. Okay, so here we'll be using database to store the information. So guys, this is going to be one amazing implementation. So make sure you watch this video till the end. So first of all, let me show you the steps. Actually, what are the steps we're gonna perform to implement the entire projects. And no need to worry, all the code, all the material would be given in the description. From there you can download. And I already created one template for this project, so you can use this template as it is if you want to implement these kinds of projects, okay, with the help of different kinds of data and all, right? So you can use my template as it is. So let me open up my Blackboard and let me show you the steps we're gonna perform. So guys, I think you already know what is license plate detection. So you can see guys, this is the high level architecture. That means we'll be using a camera. So if you want to deploy this project in the real time, what you can do, you can use this kinds of CCTV camera. Okay, with the help of CCTV camera, you can first of all collect the image. Okay, collect the image of the card. Then you can apply the object detection model on top of it. And object detection model, what it will do, it will try to detect the object. It will detect this license plate object. Okay, after that you have to pass this particular license plate, okay, this object, the detected object, to the OCR algorithm. Okay, OCR, that means optical character recognizer. Okay, so what this OCR will do, OCR will try to extract the information. Okay, extract the information which is available in the license plate. You can see, let's say after applying this OCR, this is my information I got. Okay, this information I got. Now this information, what I have to do guys, I have to store in the database. Okay, so this is the entire idea. So for this, these are the steps actually we'll be following. So first of all, here you can see, first of all we'll be detecting the license plate. Okay, we'll be first of all detecting the license plate with the help of Yolov10 model. Okay, and I think you already know, so Yolov10 is having some pre-trained model. So in the model view, if you open up the GitHub, you will see that it is having some let's say pre-trained model, and this pre-trained model doesn't have any kinds of license plate. Okay, license plate data. Okay, license plate knowledge it doesn't have. That means when they train this particular model, they use something called COCO data. Okay, COCO data, I think you know COCO is a benchmark data. So inside COCO data, license plate data is not available. So what do we have to do? We have to first of all fine tune this model. Okay, we have to first of all fine tune this model on top of our license plate data, car license plate data. Okay, then after that we'll be getting one model. The model is base.pt, I think you know. So after training any kinds of YOLO model, what we get? We get base.pt model. Okay, base.pt model. So this is going to be my trained model, and this model actually will be using for the detection task. Okay, so with the help of this model, we'll be detecting the license plate. Then we'll be recognize the text on the plates using PaddleOCR. So here we'll be using PaddleOCR. So Paddle is a OCR, optical character recognition. So this is one of the amazing OCR guys, and the accuracy is pretty good. So you can also use something called Easy OCR. Okay, Easy OCR you can also use. So in my YouTube channel, I created another tutorial related this Easy OCR. You can check it out. So that's why I took this PaddleOCR, because I want to also show you the PaddleOCR, and you will see the accuracy is pretty good. Okay, so we'll be using PaddleOCR to extract the information from the license plate itself. That means after detecting, I will get the license plate. Okay, here after getting detecting, we'll be getting the license plate, and this license plate I will be sending to the OCR algorithm. Okay, which is nothing but PaddleOCR. PaddleOCR will try to extract the information. Okay. Then what we'll do, we'll save the accumulated unique license plate to a JSON file in every 20 seconds. That means after every 20 seconds, we'll be saving this particular information to the JSON file. That means every 20 seconds, it will extract. Okay, it will extract the information from the license plate and it will save in a JSON file. Then every 20 seconds interval generates a new JSON file in a JSON file directory, and a cumulative JSON file is updated with a new interval data retaining previous entities without duplication. Okay, that means, see what I'm going to do here. Let me just simplify this particular term. So in every 20 seconds, my system will extract the license plate. Let's say it has extracted one license plate. So the license plate, let's say I'll name it as output 1.json. Okay, let's say this is my first file, and it will have one timestamp. Let's say the start time. Okay, start time, like what time it has extracted the, let's say this license plate, and then I will also let's say store the end time. So what is end time? End time means whenever 20 seconds would be done, so it will extract that particular time and it will save inside this particular JSON. That means my JSON will look like that: start time, end time, and the license plate. Okay, license plate data. Okay, that means whatever license plate, let's say, data it will extract, it will save inside that. So it will be a JSON format. Okay, JSON format. Then again, after 20 seconds, what will happen? It will again extract the information from the license plate, and again it will create another file called output2.json. Okay, and inside that it will again store the information, the start time, end time, and the license plate. Okay, that's how after 20 seconds, okay, again after 20 seconds, it will again let's say save another file, again save another file. That's how if you are using video, based on the video frame, actually this execution will be running. If you are using the camera, that means whole day actually it will be tracking. You can also change the time. Let's say you want to do after 1 hour, let's say after 10 minutes, you can also change the time. It's up to you. So here I'm keeping 20 seconds because I want to show you as a demo. Okay, that's why. Then we'll be also creating something called cumulative file. And what is cumulative file? See, I'll be creating another file which would be my main file. Okay, let's say my final.json. Okay, let's say this is my final file. So inside that, what I will do, we'll take all the information. Okay, let's say first of all I will let's say open the output.json, and whatever information I am having, I'll store inside this particular file. Okay, then output2.json, I'll store inside this file. Now let's say if there is any duplicates, let's say inside output1, output2, inside output3, the same license plate it is storing. What I will do, I'll be only taking the unique, not the duplicates. Okay, that means I'll be only taking the unique. So this file will contain the unique, okay, unique plate information. That means this is going to be my final let's say file. So whatever, let's say, execution I'm doing, whatever file we are saving after 20 seconds, so at the end we'll be storing all the information inside one file, which is nothing but my cumulative JSON file. Okay, I hope you clear. Now after that, what we'll be doing, we'll be also saving. Okay, we'll be also saving this particular, let's say, information, whatever, let's say, final file you are getting, final.json, will be saving inside a database. And here we'll be using SQL database. SQLite database will be using because it's easy to set up. It is already available in your system. If you're using Windows machine, if you're using any other machine, it is already available. So you don't need to set up it. Okay, manually you don't need to set up it. So in case, you can also use like MySQL data, you can also use MongoDB, any kinds of database you can use. It's up to you. Okay, only just you need to know how to set up the database. That's it. And this dataset is like very lightweight. Okay, that's why we'll be using this particular data. You are feel free to use any kinds of data, guys. Okay, so here I'm showing you with the help of SQLite, you can use any kinds of data. It's up to you. So first of all, let me show you the demo of the project. I think then this part would be clear. Okay, how actually it will save the information and all, and how your information will look like. I know that initially it would be a little bit like confusing for you to understand, okay, what I'm going to do, but after seeing the demo, you'll be able to understand, okay, what I'm trying to perform here. So see, first of all, what I have to do, guys, first of all, I have to train one Yolov10 model on top of our car license plate data. So in this video, I already told you I'll be using one new state-of-the-art object detection model called Yolov10. And this is like recently released model. And this is one of the amazing Yolov variant you will see. So this is the benchmark of Yolov10. You can see Yolov10 is performing better than your previous version of the Yolov. And it is like also good with the video. That means if you are if you want to do, let's say, real-time object detection. So if you want to perform real-time object detection, so you can use this model. It is one of the amazing model because here you will get very low latency. And it is having different model variant. I will also show you like how many different model variant it is having. So this is the official paper of the Yolov10. So if you are interested in learning Yolov10, like what kinds of architecture they're using, so you can deep dive in this particular paper. So I'll give the link in my description section. So from there, you can open this particular paper. Now let me show you the official implementation of the Yolov10. So this is the GitHub, guys. And inside the GitHub, actually, you can see like they have given everything. Now here you can see the variant of the model. It is having different model like Yolov10, N, then S, M, B, L, X. Okay, so these are the model variant it is having. N means this is the nano model, S means smallest model, M means medium model. Okay, that's how it is having a little bit bigger model. Now you can see the installation of Yolov10. I will show you the easiest way you can follow to install this Yolov10. Okay, in your Google Colab. So here we'll be using Google Colab to implement the entire project. So let me show you guys. I already prepared one Colab notebook for you. So the first thing what you have to do, just connect with the runtime. So that means I want to connect with my GPU. So I already connected with my GPU. Now let me connect my notebook. This notebook would be available in the description section. So from there you can launch up and you can start the coding with me. So in between, let me show you the dataset actually we'll be using here. So guys, the dataset actually I'm using here, I downloaded from RoboFlow. So let me show you. So there is a website you can always refer if you want to get any kinds of data or any kinds of computer vision related help. You can go to this particular website called RoboFlow Universe. So inside RoboFlow Universe, you will get all kinds of data related computer vision. It can be object detection, it can be image segmentation, it can be classification. All kinds of data is available. So this is the universe. Okay, universe means here you will get the data. Okay, all kinds of data, and you see the count of the data. Okay, now there is another website, RoboFlow official, like roboflow.com. So here you can create an account, and in this particular platform you can do the annotation of your data. Even you can also train your model. Okay, even you can also deploy your model. Everything is possible here. Now, as I already told you, I'll be using one dataset called a license plate dataset. So you can see if I search this dataset here. So if you search anything in that search bar, you will get all kinds of data. Now see, you will have different license plate data. Okay, now you can download any of them. Let's say I want to download this one. So I'll just click here. So now you'll see one button called download project. Just click here. Now here you will get one option called download this dataset. Just try to click on the dataset. And here you have to select the format of Yolov10. Okay, because Yolov10 and V10 format are same, so you don't need to worry about. Just select the Yolov10 and try to download as a zip file. Either you can also download as a code, but I will be downloading as a zip file. Now if I click on continue, so it will download this dataset in my system, and it will be a zip file. Okay, and your zip file, what other things would be available? Let me show you. So guys, you will get this kinds of zip file. Now if I open this zip file, so inside that you will have three kinds of folder: test, train, and valid. Inside that you will be having the images. So let me show you. So this is the images. Okay, this is the car images with the number plate, and you also have the annotation file, the txt annotation, because it's a YOLO format annotation. So here is the txt file. So it will have the label as well as the coordinate point of the license plate. Okay, so that's how actually in the all the folder actually will have this particular data as well as the annotation file. And you will get another actually file called data.yaml. So let me open the data.yaml and let me show you. So this is the data.yaml, guys. Inside data.yaml, what you have to do, you have to mention the data location, like what is the image path. Okay, and number of classes. I'm having only one classes, that's why I've given one, and the class name is license. Now if you're having multiple classes, you can also mention here. Okay, it's up to you. I already explained so many times this thing. Okay, how we can create this data.yaml file. Fine. So now let me close. These are the file I don't need as of now. So I'll get back to my notebook. Now, first of all, let me check whether I got the GPU or not. So for this, you can execute this NVIDIA SMI command. And here I got the Tesla T4 GPU. Now, first of all, what I have to do, I have to clone the repository of the Yolov10. So here, just open the repository, click on the code, copy the link address and try to paste here. Now see, if I execute this line, it will clone the repository in my Colab notebook. Now, first of all, I have to redirect to the folder. That means in this particular folder. So for this, I will be running the cd command. Now, if I show you my current working directory, I'm inside this Yolov10 folder. Fine. Now, what I have to do, I have to install the packages, all the required packages. For this, you can execute this command, pip install dot. So this dot will install all the required packages. Okay, you have here. So installation is done. Now, what you have to do, you have to download some of the model. Okay, download some of the model from the model zoo. And this is the link. Okay, this is the link for all the model. Now, if you want to download the model, just try to mention the link of the model. Okay, you will see this model is available inside this folder. Now, here I've written a code snippet. It will download the model one by one from this particular URL. Now, see, if I execute the program. So here I've added a for loop. So it will loop through this URL and it will download the model one by one with the help of request package. That's the idea. Now, see, it will create a folder called weights. Now, inside that, it will download all the model. See. All the model, you can see it has downloaded. Fine. Now, what I have to do, I have to upload my data. So what I can do, I can upload the data here. So let me upload. Just click on upload button. Make sure you're uploading inside Yolov10 folder. Now I'll upload my data. So this is my zip file. I'm going to upload it here. So guys, as you can see, my data is uploaded. Now if I refresh here, so license data is available here. Now I have to unzip this particular file. For this, just execute this command. Now see, my file has been unzipped. Now I can see my custom data set. Okay. Now see, all the files and folders are available. See, all the folders are available. Now I also need to upload another file, I think you remember, which is nothing but my data.yaml file. So let me also upload here. I'll upload. So this is my data.yaml file. I'm going to upload it here. Again, I'm uploading inside Yolov10 folder. Fine. All right. See, it is also uploaded. Now you can directly start the training for this. You can use this particular command. So let me train as of now 50 epochs, or I can train 100 epochs because I want to get a good model. And see, here you have to do, you have to run one command called YOLO. You have to give the task. That means you want to perform the detection. Then you have to give the mode. You want to do the training, okay? Custom training. That's why mode is equal to train. Epoch, I am training 100 epoch. Bash is equal to 16. You can decrease and increase based on your machine configuration. Plot true, that means it will create a runs folder. Inside that it will save all the artifacts, and here I have to specify the weights. So here I'm using Yolov10 nano model, so it is available inside weight folder. I think you saw nano model. Okay, this model actually I'm using. You can also use any other model, okay, based on your requirement. Now here I'm passing the data.yaml file path. Okay, so here is the my data.yaml file path. Okay, because inside that I'm having all the location of my data. But one thing you have to change here. So you can see this is the actually current path, but I need to change the complete path. So I'll just open inside that. I'm going to change all the path. Now let's say inside training folder I'm having the image. I'll copy the path, and here let me mention. That means you have to give the complete path. Okay, this is the complete path right now. Now for the validation as well, I also need to do the same thing. So I'll copy path, and here let me mention it here. Okay. And as of now, I don't need the test image, so I'll just try to remove, because for the training, I only need training and validation image. Now let me close it. Everything is fine. Now I think I can start the training. So just click on the train. Okay, this one, it will start the training. So training may take some time, guys, because here we are using free collab. So let's wait. Once this training is completed, we'll come back again and we'll try to test this particular model. So guys, as you can see, my training has started and epochs is going on, and per epochs you can see the losses as well as the MAP score. So let's wait. Once this training is completed, I will come back. So guys, as you can see, my training is completed and it has saved all the artifacts inside this runs folder. So let me open the runs. Inside detect, I'm having this training. Now inside that you will see all the artifacts, that means all the matrices. Now if you want to see them, you can open this result.png and you can see the performance of the model. So this is the complete results. So you can see losses is decreasing as per your epochs is increasing, and here your MAP is increasing as per your epoch is increasing. That means your model is learning better. You can see there is no zigzag, it is learning better. Now what I can do, I will just check whether this particular model is performing on top of my test data or not. So for this, I will do the inference operation. Now inside that, I'm going to upload one image first of all. So see, model would be available inside Byte folder. So this is the model. Base.pt is my model. Okay, this is my trained model. Now inside this Yolov10 folder, I'm going to upload one testing image. So I'm having the test image here. So let's upload this image. I think it is card.jpg. Okay, so this is the card, and it is having one license plate. Now let's try to see whether it is able to detect or not. So to detect, you just need to perform this command. YOLO task is equal to detect. You want to detect, and mode is equal to predict right now because you want to only do the prediction. Confidence score, as of now I've given 0.25. You can also increase and decrease as per your requirement. Save is equal to true. That means it will save that particular let's say result, and you have to give the model location. Now model is available inside my runs folder. I already showed you now. Runs, detect, train. Okay, so it should be train, not train 2, because I previously did multiple experiment. That's why. Now this is my base.pt model and source image my card.jpg. Okay, so here is my card.jpg. Now if I execute the program, it should detect that particular license. Let's see. We can also do the same thing on top of the video. I will also show you how we can do on top of the video. Now see, detection is done. Now if I show you my runs folder right now, it has created another folder called detect. You can see detect, predict, and inside predict I have my prediction. Now see, card.jpg. Now if I show you the prediction, see, beautifully it has detected the license plate with the confidence score of 0.990. That means 90% it is confident it's a license plate. That means amazing detection, guys. Although you have used nano model and trained 100 epochs, but still the prediction is pretty good. Okay, now let's try on top of the video. So what I'll show, I will upload one video here inside the Yolov10 folder. I'm having one video. So video is available here. So this is the video. So let me show you the video once. So here's the video, guys. So some cards are moving here, So we'll just try to apply the model on top of this video and let's see whether it is able to detect or not. And let's see the performance of the model, okay, how it is able to detect in real time. Now I think it has uploaded. Now let me check video MP4 uploaded. Yeah. Now to perform on top of the video, this is the command you have to execute. The same command, only you just need to give the video location here. Source is equal to video.mp4. Okay, that's it. Now let me execute. And if you want to perform on top of the camera, source is equal to 0 you have to give. It will access your camera. And you have to set up everything in your local machine. So as of now, we are running everything on our Google Colab. So that's why it won't be able to access our camera. But if you want to perform on top of the camera, just give 0 here after setting everything in your local machine. Okay, this is the idea only. So now see, it has done on top of the video as well. Let me refresh. Let me show you. Let's inside detect, predict 2. And here is the video file. Let me download and let me show you. So guys, as you can see, my video is downloaded. Now let me open it up and let me show you the detection. See, amazing detection, guys. You can see real time it is detecting the license plate. Okay, these cars are moving actually. So same thing you can also perform with your web camera. As I already told you, only you just need to give the source is equal to 0. Okay, that means your camera location and everything you have to set up in your local machine. That's it. Now let's try to do the coding. That means we'll be creating the project. For this, what I've done, guys, I've created one amazing project template for you. So if you want to perform this kinds of project, so you can use this particular template as it is. So please try to start the repository, try to also fork it so that you will be having, okay, in your let's say account. Now what I will do, I'll just try to clone the repository. So here I already given all the step how you can set up this repository. Okay, what are the command you have to execute? See, all the command I have already mentioned. So guys, the first thing we have to clone this repository. So let me copy the URL. So make sure you are clicking on the code, copy the URL, open up the folder, and you can open up your git bash. So this is my git bash. So here I'll write one command called git clone and I will paste the link. See, it is cloning my repository. So guys, as you can see, we have cloned the repository. Now what I will do, I will open it up and inside that I'm going to open up my Visual Code Studio. So this is my Visual Code Studio. So here the next is you just need to create one virtual environment. Okay, so with the help of Python 3.11 you have to create one virtual environment. Just try to copy and try to execute from the terminal. So it will create a virtual environment for you. So for me, I already created. I'll just try to activate it. So this is the command. So you can see I've activated. Now the next thing, you have to clone the Yolov10 repository because I think you remember we already trained this model with the help of Yolov10. Yes or no? And after like training the model, we need to also download the model. That means our base.pt. And where you will get the base.pt, inside runs folder, you will get that particular base.pt and you have to download the model. So for me, I already downloaded the model. Let me show you. So the model. So this model is available inside Boit folder. You can see. So the model actually I trained, I already downloaded the model from the Google Colab. Then you have to keep inside this Boit folder. Okay. Then if I want to use this model, so definitely I have to first of all set up this Yolov10. Okay, Yolov10, right, in my environment. So for this, what I have to do, guys, I have to clone the repository, and after cloning, I have to set up this requirement. So this is what actually we'll be doing. So here is the command. First of all, you have to clone the Yolov10. So just try to copy paste the command and execute in your terminal. After that, you will see that it will automatically clone this Yolov10 repository. See, the Yolov10 repository we have cloned. Then we'll be setting the requirements. So how to set up the requirements? This is the command, guys. So first of all, you have to set up the requirements which is having inside my project folder. You can see requirement.txt. Let me show you. So here is the requirement, guys. So this is the requirement. So these are the requirement actually you have to install. So you have to install Hugging Face App, PaddleOCR, Paddle, and DB SQLite. Okay, so these are the packages you have to install. So first of all, execute this command. So copy this command and try to execute from here. For me, I already installed everything. Okay, it is telling could not find. Okay, so first of all, what I have to do, I have to go inside this folder, because I am inside the new folder. So I'll just write cd license plate. Now see, I'm inside this folder. Now I'll clear. Then I will execute this requirement file. See, now for me, it is already satisfied because I already installed. But for you, it will take some time and you have to complete the installation. Okay. After that, you have to go inside Yolov10 V10 folder. That means there is a Yolov10 folder. You have to go inside that. So open up your terminal. So this is the command. So copy this command and execute here. You'll see that I'm inside Yolov10 folder. Now inside that you have to install all the requirements. So this is the command. So pip install -e space dot. Now just execute the command here. Okay, so let me copy. Okay, now see, if I execute, it will install everything. Okay, for me, I already installed everything. Okay, that's why I don't need to do it, but for you, it will take some time. See, for me, it is telling requirement is already satisfied. Okay, once it is done, again you have to get back to your root folder. So for this is the command you have to execute. A cd a space dot dot. Now you can see that I'm inside my root project directory. Okay, then what we have to do, guys, we have to execute this SQLDB.py. But before that, you may face some issue. So I was executing the project and I was getting some dependency issue. So how to fix the issue? So for this, you have to execute these two commands. First of all, copy this command. First of all, you have to uninstall the numpy. Okay, the latest numpy, and then you have to install this particular numpy. Okay, done. Now once everything is completed, make sure, guys, you have executed all the command, whatever command I showed you step by step. Then you will be executing this SQLDB.py. And if I open this SQLDB, you can see it will create a database for me. Okay, it will create a database for me. You can see I'm connecting with the database. So this is the database it will create. And inside that, it will create some schema. You can see, first of all, it will create the start time, then end time, then the license plate information. And this is the data type. Okay, if you know about like database a little bit, I think you know, okay, what I'm trying to do. So first of all, let me create a database. So let me copy the command. So I'll copy and let me execute it here. See, I'll clear. And here I'll execute. So for me, I already created, first of all, try to delete. Okay, I'll try to delete everything. Inside JSON folder also, I'll try to delete everything because I already executed this project previously. Okay. So everything is fine. So now let me create the database. So guys, you can see my database is created, and I think you know SQLite is a local database. Okay, and I have already given you some data inside data folder. So some different kinds of video I have already given you, so you can use this video. So we'll be using these are the video to test our application. So this is one of the video, this is another video, and this is another video. So you can see cards are moving and we can see the license plate. Now we'll try to detect and extract the information and we'll be storing in the database. So I also given you some of the images. You can see some images also I have given you. All right, and inside notebook folder, I already provided the notebook I showed you, the collab notebook, so that you will have all the reference in one place. And in the weight folder, I have my base.pt model. Make sure, guys, you train your own model and you can keep it here. You can also use my model. I will also share with you my model. Okay, you can also use my model. Then you have to create a JSON folder. Okay, inside JSON folder, initially it would be empty. After executing my application, it will save all the information in a JSON format. So yes, these are the files and folder, guys. I think you got it. Now let me open it up. So my database is created. Now the next thing, I have to execute my main.py. So here is the command main.py. So let me execute the main.py. But before executing, let me explain what I have written inside main.py. So guys, you can see this is the main.py. So here I'm importing some necessary library. You can see I'm importing Yolov10, NumPy, math. Okay, then datetime, PaddleOCR. Then I'm also importing SQLite database. So I'm importing all the necessary library. Then I'm setting this environment variable because if you're using PaddleOCR, so sometimes you will get some warning and error. So to prevent this error, what you can do, guys, you can write this line of code. So if you go to the Paddle documentation, you will see that they are also writing. Then with the help of OpenCV, I'm loading the video. So first of all, I'm loading this video. You can see if I show you inside data, I'm loading this video. Okay, this is the video. Or what I can do, I can load this video. I think this video is a little bit bigger. And in this video, actually, like so many objects are available, like so many cards are available. So I can use this video. I think that would be fine. So instead of loading this video, I'll load this video, number 4, card license number 4. Then I'm loading the model. So the model actually I trained, it is available inside void folder. I'm loading the model. Okay. Then class name is license. I'm initializing the PaddleOCR. And here I've created a function called PaddleOCR. So this function will try to extract the information from the license plate. It will take the coordinate point. That means this coordinate point it will take. This 4 coordinate point it will take. Okay. So whenever you will perform the detection, after detecting, you will get the license plate coordinate. So this, license plate you have to pass. And how to pass with the help of coordinate point. and after that it will extract the information. Okay, so this function will try to extract the information. Then after that we'll be saving as a JSON. So it will take the start timing, end timing, as well as the license plate information. Here I'm creating the dictionary. After that I'm creating the timestamp like file and all. Then guys, you can see I'm creating this individual JSON file. So the things I have explained, I think you remember here. So first of all, after 20 seconds, it will create different JSON file. Okay, so this is what actually we are doing. Then after that, we are getting the cumulative JSON file. That means our final JSON files, which would be license plate data.json. Inside that, it will save all the unique license plate information. Okay, now once it is done, once we have saved the information to the JSON, then I'm saving inside SQL database. So this is the function I have written. Okay, save data to the SQL database. Now this is the function, guys. So it will take all the information and it will store the information to the database. And for this, first of all, you have to create the database. So we have already created a database, you can see. So this database we are loading and we are storing the information. And I will tell you how we can visualize the information inside database. For this, which tool you can use. We'll be using one online actually viewer, SQLite database viewer. With the help of that, we can see the information inside that. Then this is my final loop. Inside that, I'm performing all the thing. I'm loading my video frame. Then I'm loading the model. I'm doing the prediction, getting the bounding boxes. Then you can see I'm performing the PaddleOCR. That means I'm extracting the information. After that, you can see here I'm saving the information. Okay, I'm saving the information as a JSON file as well as the database. So if you execute this function, it will save as a JSON file as well as the database. So guys, please try to open up this code in your code editor and try to go through this code, whatever things I have written step by step. And you don't need to remember this code, guys. This kinds of code is already available over the internet. You can copy paste from there. Only you just need to do some slight modification. The modification I have done, I created separate function. You can see I created separate function. And what I'm doing, I'm using all the function inside a one place only. Okay, I think you know how to read the frame, how to get the bounding boxes, okay, how to get the coordinate point. Then we already know how we can show this particular video in my window. So this is like basics of OpenCV. So previously, maybe you have learned OpenCV. So inside OpenCV also used to perform the same thing, right? So if you're already familiar with OpenCV, I think you already know what is happening inside this loop. That's it. And this template you can use as it is. If you're getting any kinds of project related that, you can use as it is. Okay, only you just need to change the data. Now, this is what actually we have written. Now, let me just test whether everything is working fine or not. So I have already deleted everything. Now I'll open up my terminal and Python main.py. Now see the things, guys. Okay, what I'm trying to say. So guys, you can see my execution has started and this is the window. Now you can see, guys, it is detecting as well as it is also extracting the license plate information. Now if I open the JSON folder, see, now if I open the JSON folder, now you can see, guys, it is saving the information after 20 seconds. Now if I show you, see, first of all, it has created output and this is the timestamp. It has saved the information. Now see, now inside this JSON, you can see start timing, end timing, and the license plate. Okay, the license plate information it has saved. Now again, after 20 seconds, after another 20 seconds, it will save another output. And this is the information. And this is my final JSON file. Inside that, you can see whatever information it has extracted inside output and output, let's say 1 and 2. All the information would be available inside only one file. Now you can see this information is available here also. Okay, now see, after another 20 seconds, it will create another, let's say, output. And if you open the license plate, that means your final file, you will see that this information would be saved here. That means this is going to be my final file. And this will contain all the unique license plate, guys. Okay, you can see it is detecting. It is extracting the information. Now see, so guys, you can see my execution is completed because I was using the video. So video is having some certain frame. So frame is completed. And you can also use the camera. So if you want to use the camera, so what you have to do? So here you have to give the camera ID instead of loading the video. You have to, so if you want to use camera, so here you have to give the camera ID. I think you know how to load the camera inside OpenCV. So this line of code you have to only change. That's it. So guys, now you can see this is the final output I got. Now these are the information is also saved inside the database. Now I can't open the database. Okay, it's not possible inside VS Code. So for this, what we will be doing, we'll be using one amazing online viewer called SQLite viewer. So here is the link I have given in the GitHub. So now I'll just try to upload this file. So this is my database file. Try to upload it here. Now see, guys, that's how your information will look like. Now this is the start timing, end timing. This is the information. This is the start timing, end time. This is the license plate. Okay, start time, end time, license plate. Now you can see all the information it has saved. Now sometimes you can see it has also extracted some unnecessary information. It has also extracted some unnecessary symbol, but these are the thing you can also filter out. And see here, PaddleOCR is a free OCR, and we know that if something is free, definitely you won't be getting 100% accuracy. Okay, and if you want to apply this project in the real world scenario, that means if you want to create a real world product, that time you'll be using more powerful OCR. You can use AWS OCR, you can use Azure OCR, some cloud-based OCR service you have to use that time. Got it? Now I think you got it, guys. The entire idea how we can create this kinds of project. If I want to detect the license plate, if I want to extract the information, and if I want to save as a database, save inside a database, so how we can perform. Okay, now all the resources would be available. Please try to clone and try to execute in your system. And if you're facing any kinds of error, you can let me know. So yes, guys, this is all from this video. I hope you like this video. So thank you so much for watching this video, and I will see you next time.